One of India's most celebrated successes that have enamored the world is its Mars orbiter mission, the maiden interplanetary mission of ISRO, which was launched on November 5, 2013 by the PSLV C-25 rocket, was put into Martian orbit on September 21, 2014 in its first attempt. The Mangalyaan, or the MOM, has completed about 1,100 days in orbit. India's $74 million, called the Mangalyaan, was roughly a tenth of National Aeronautics and Space Administration, called NASA's Mars mission Maven. This spacecraft was designed to last for only 6 months or the 180 days in the Martian orbit, but had surpassed all the expectations. It has completed 4 years in space. India's Mars mission was launched on November 5, 2013 from Sriharikota in Andhra Pradesh. On December 1, 2013, it escaped the Earth's gravitational field to its 10th month along or the long space odyssey. After completing its 300-day journey, the spacecraft successfully entered the Martian orbit on September 2014 21st, making India the first country in the world to have successfully reached Mars in its first attempt. During its entry into the Martian orbit, the Mangalyaan was carrying 40 kg fuel load. In June this year of 2017, the Mangalyaan had spent 1,000 days of Earth in Martian orbit. During this period, the spacecraft had completed 388 orbits around the red planet Mars. Here are the few things that Mars mission of India, or the ISRO's interplanetary mission, succeeded in Mars. The focal objective of MOM, or the MOM, is to work on the technologies required for designing, planning, managing and operating an interplanetary mission for the future of ISRO. It was easily the least expensive Mars mission till date, which was also the first attempt successful. It is also secondarily working on obtaining data penetrating to the red planet's surface features, morphology, mineralogy, and the Martian atmosphere. MOM's competence is driven by the presence of these tools: a color imaging camera, a thermal infrared spectrometer to measure the chemical compositions of the surface, and instruments to assess Mars' atmosphere. It also has produced over 715 images till date. MOM is also well equipped to take care of itself for longer periods without any ground interventions. It's a matter of great pride that India's, or the ISRO's, Mars orbiter mission have exceeded expectations and is helping us pave way for the bigger and more elaborate and the path-breaking mission for India and its scientists of ISRO, or the Indian Space Research Organization. So what do you think of ISRO's Mars mission Mangalyaan has successfully crossed 1,100 days in Martian orbit, which was tend to be only 180 days or 6 months.
NASA's newest Mars spacecraft, Maven, is currently on a mission to determine how Mars lost its early atmosphere, and with it, its water.
The questions that Maven is trying to answer deal with the history of the Martian climate. From the previous missions, we have a lot of evidence that that climate has changed over time, that early Mars was warmer, wetter than present-day Mars. What we're trying to answer with Maven is, where did all that water go? Where did the carbon dioxide from an early thick atmosphere go? And we're doing this by studying the top of the atmosphere. Since we are the first mission really looking at all pieces of the puzzle on the upper atmosphere, almost everything we're seeing and how it relates to everything else is brand new. As an example, one of the things we measured very early in the mission, right after we went into orbit, before we even got into our final science mapping orbit, was the distribution of hydrogen, oxygen, and carbon as a cloud surrounding the planet, the very extended upper atmosphere.
In this ultraviolet image, carbon and oxygen cling tightly to Mars, while hydrogen, the lightest element, extends well above the planet. Understanding the escape of hydrogen is important because hydrogen is the primary ingredient in water. While previous Mars orbiters have peered down at the planet's surface, Maven is spending part of its time gazing at the stars, observing the Martian atmosphere through a series of stellar occultations.
The imaging ultraviolet spectrograph, the IUVS instrument, can determine properties of the upper atmosphere all the way down to the lower atmosphere by looking at a star as the star sets behind the planet as seen from the spacecraft. And by looking at the diminution, the weakening of the starlight as it sets, we can measure the composition of the upper atmosphere.
The relative motion of the stars allows Maven to look at columns of the atmosphere, revealing how its composition changes with altitude. At the same time, Maven's orbit passes close to the Martian polar caps, giving it north to south coverage of the planet. Mars itself rotates once a day beneath Maven, providing east to west coverage. This combination allows Maven to observe the entire atmosphere.
My goal with Maven is to put together a data set that the Mars science community can spend the next decade or two working on. We're making very few measurements that have never been made at all before at Mars, but what we're doing is we're making them in parts of the atmosphere where they haven't been measured. We're making comprehensive measurements for a full year rather than, for example, with the Viking lander, a one-time entry, one profile. We're going to get hundreds and hundreds of profiles and be able to see how the upper atmosphere responds to the changing solar conditions and really put together a picture of the upper atmosphere that we haven't been able to put together before.
Post your comments below. And if you like this video, please give a thumbs up. And follow us on social networks. And subscribe to our channel. And thanks for watching. This is WC Daily. Think big, think different. Bye.